Have you ever wondered about our sister planet, Venus? It's almost the same size as Earth, made of the same stuff. But while Earth is a paradise of liquid water and life, Venus is a nightmare. The surface temperature is over 900 degrees Fahrenheit, 475 degrees, hot enough to melt lead. The atmospheric pressure is 90 times ours, a supercritical fluid of carbon dioxide that would crush you in an instant. Why is it so different? Because Venus is the ultimate victim of a runaway greenhouse effect. This isn't just more climate change. A runaway effect is a one-way street. It's a terrifying positive feedback loop. It's the moment when a planet's climate stops being a stable system and becomes a self-fueling fire. So, what if it happened to us? What if we accidentally pushed our own planet past this irreversible tipping point? This isn't a guide for how to reduce your carbon footprint. This is a desperate 7-step scientific guide for how humanity, as a species, would attempt to survive a true Venus-style end-of-the-world apocalypse. Before we start our guide, what would this runaway even look like? It all starts with water. As Earth warms, the oceans evaporate. This puts more water vapor into the air. But here's the kicker. Water vapor is the most powerful greenhouse gas of all. So more heat, more evaporation, more water vapor, even more heat. This is the positive feedback loop. Once we hit a certain temperature, around 130 C average, the oceans would begin to evaporate at a catastrophic rate. The atmosphere would become a thick, soupy global steam bath. The planet would be on a one-way trip to becoming Venus 2.0. So the signal is given. The oceans are steaming. The world's leaders are in a panic. The Venus scenario has begun. Here is our only path forward. The first step in survival is knowing you're in a disaster. We wouldn't just wake up to 900-degree temperatures. We'd first enter a stage that scientists call the moist greenhouse. This is the point of no return. The troposphere, our weather layer, becomes so hot and saturated with steam that it pushes water vapor high up into the stratosphere. This is very bad. Up there, intense ultraviolet UV radiation from the sun would do something terrible. It would split the water molecules, H2O. The oxygen, O, would react with other things, but the hydrogen, H, the lightest element, would be light enough to escape Earth's gravity entirely. It would bleed out into space. This is the true alarm bell. We aren't just in a hot phase, we are permanently losing our planet's water to space. We can no longer fix the surface. The only strategy is to flee it. The surface is now officially a lost cause. The air isn't just hot, it's becoming a high-pressure supercritical fluid, a bizarre state between liquid and gas. The wet bulb temperature, the point at which sweat can no longer evaporate to cool you down, would be surpassed globally. Any human on the surface would die of hyperthermia in hours. So, where do we go? Not up. The only option is down. This is step 2, a planet-wide triage. We must abandon the surface entirely. We must begin the single greatest engineering project in human history, Operation Deep Bore. We would need to build massive self-contained cities, or Arcologies, deep within the Earth's crust. Why? The crust is an amazing insulator. Just a few hundred meters down, the lethal surface temperature becomes irrelevant. The temperature is instead dictated by the planet's geothermal gradient, the natural heat of the Earth's core. We wouldn't be digging with shovels. We'd be using our last remaining industrial power to build massive tunnel-boring machines, drilling miles deep into the stable granite of mountain ranges and continental shields. These would not be bunkers. They would be the permanent, hermetically sealed homes of the human race. We would need to build massive, self-contained cities, or Arcologies, deep within the Earth's crust. Why? The crust is an amazing insulator. Just a few hundred meters down, the lethal surface temperature becomes irrelevant. The temperature is instead dictated by the planet's geothermal gradient, the natural heat of the Earth's core. We wouldn't be digging with shovels. We'd be using our last remaining industrial power to build massive tunnel-boring machines, drilling miles deep into the stable granite of mountain ranges and continental shields. These would not be bunkers. They would be the permanent, hermetically sealed homes of the human race. How do you power a 1-million-person city miles underground? You can't, not with any conventional source. Solar is gone. Wind is gone. Hydro is gone. All fossil fuels on the surface are inaccessible or destroyed. The answer is right beneath our feet. We must master geothermal energy on an unheard-of scale. We would be drilling deeper still, not for shelter, but for power. We'd use Enhanced Geothermal Systems, EGS, pumping water, now the most precious resource on the planet, down into engineered hot rock zones, thousands of degrees hot, and using the resulting superheated steam to drive massive turbines. Our entire civilization, our lights, our life support, our everything would run on the very heat that is killing the planet above. We would be living inside our own power source. You can't just seal 1 billion people underground. We have to create a perfect closed-loop artificial biosphere. This is where physics meets biology. Air we can't vent to the surface. The atmosphere is now a toxic, high-pressure brew. Every breath of air would have to be 100% recycled. We would use massive algae bioreactors, vast glowing green tanks of genetically engineered algae. These algae would be our new rainforests. They would scrub the CO2 from the air we exhale, and using the light from our geothermal-powered LEDs, produce the oxygen we need to breathe. Food. Agriculture is over. We would move to synthetic biology. We'd grow food without soil, giant vats of yeast and bacteria, genetically modified to produce all the proteins, fats, and carbohydrates we need. This vat-grown food would be flavorless, monotonous, but it would keep us alive. Water. This is the hardest part. The planet's water is escaping into space. Every drop in our underground arcs would be sacred. We would need a 100% closed-loop water recycling system. Every molecule, from urine to humidity from breath to waste from food production, would be captured, purified, and put back into the system. There is no new water. There is only the water we have. We cannot live in the dark forever. Hiding is a short-term solution. To survive as a species, we must eventually reclaim the surface. But how do you cool an entire planet that's on fire? You have to block the sun. This is step 5, the greatest geoengineering project ever conceived. We would need to build a global sun shield. We're not talking about seeding clouds. We're talking about building a permanent physical barrier in space. The shield would be built at the Lagrange point 1, L1, the stable point between the Earth and the Sun, where a shield could hover. It would need to be a vast, diaphanous structure, millions of square miles wide. What's it made of? We can't launch that much material. We'd have to mine the moon and asteroids. We'd build robotic factories on the moon, strip mining its regolith for aluminum and silicates, and launching the raw materials into space with electromagnetic mass drivers. Autonomous robots would assemble the shield in space. It would be a smart shield, perhaps made of trillions of tiny self-aligning mirrors or solar sails, capable of reflecting just the right percentage of sunlight, not 100%, or we'd freeze, but enough to stop the runaway effect and slowly, over centuries, bring the temperature back down. Let's assume the sun shield works. It's a process that would take millennia. The surface, still a high-pressure oven, would slowly begin to cool. The supercritical CO2 atmosphere would eventually start to condense and fall as carbonic acid rain. The oceans, now acidic and dead, would reform. Our descendants, still living in the underground arcs, would become the planet's gardeners. Their job, terraforming our own home. This is step 6, the Great Reseeding. We couldn't just open the doors. We'd have to send robotic probes and bioengineered extremophiles to the surface first. First wave, genetically engineered microbes would be released. Their job would be to feast on the acidic, CO2-rich atmosphere and the poisoned oceans. These microbes would slowly, over thousands of years, reoxygenate the atmosphere and neutralize the seas. Second wave, once the air is breathable and the temperature is survivable, a process that could take 100,000 years, we would send out the hardiest, most basic life from our genetic arcs, the mosses, the lichens, the fungi. These would be the organisms that could break down the sterile rock and create the first new soil. Final wave. Only after the soil is laid and the atmosphere is stable could our great-great-great-grandchildren, thousands of generations removed, finally begin to reintroduce complex plants and eventually animals. The final step isn't a project, it's an acceptance. The Earth we reclaim would not be the Earth we lost. The runaway effect would have sterilized the planet. Mass extinction would be total. The new biosphere would be built entirely from the limited genetic library we managed to save in our arcs. The continents would be in the same place, but the climate, the coastlines, and the very color of the sky might be different. But humans would have changed too. Thousands of years living in high-pressure, artificially lit, closed-loop environments would have changed us. We may have engineered ourselves to be more efficient, perhaps requiring less oxygen or being able to subsist on the synthetic food. The humans who emerge from the arcs would be as alien to us as the new planet they are inheriting. They would be true survivors, a species that looked into the fiery furnace of Venus, refused to be consumed, and through sheer, desperate, multi-millennial effort, built a new Earth from the ashes of the old. This is the hard, cold reality of survival. It's not about individuals in bunkers. It's about a species transforming itself and its home on a geological timescale. It's the most terrifying project in history and the ultimate test of our will to exist.